So in the previous video, we introduced what a chemical reaction is, the parts of the chemical reaction, the fact that reactants are on the left-hand side of this arrow, products are on the right. States of each species are written in parentheses next to the molecule. So in this first reaction, I have CH4 and O2, which are both gases, combined to react and give me CO2 gas and water gas. And then we also talked about how in chemical reactions, when we express them as chemical equations, that number and type of atom on the left has to equal number and type of atom on the right. And to balance a chemical equation, you must always, always, always use coefficients. That's numbers out front of each species. Always coefficients. So this equation, which is from the previous video, has been balanced by putting the coefficient 2 in front of the oxygen and of the water. Putting that coefficient there now gives me a balanced chemical equation, and I can go back and double check and make sure that the number and type of atom on the left is equal to the number and type of atom on the right. So on my left-hand side, I have one carbon. I have one carbon on my left-hand side. I have one carbon on my right-hand side. I have 4 hydrogens on the left. I have, on my right, I have 2 times 2, 2 times 2, or I have 4 hydrogens. On the left-hand side, I have 2 times 2, or 4 oxygens. And let's go back over on my right-hand side. I have 2 oxygens here. And this 2 not only goes to the hydrogen, but it also goes to the oxygen. So you can think about that as like 2 times 1 or 2. So 2 plus 2, I've got 4 oxygens. So I now have a balanced chemical equation. So let's do 2 more examples. I have solid lithium reacting with nitrogen gas to give me solid lithium nitride. So many times when you balance a chemical equation, sometimes you can just do it upon inspection, meaning looking at one atom at a time and then writing the coefficient that's necessary. So in this instance, I've got 1 lithium on my reactant side. I have 3 on my product side, so that means the only way I can get 3 lithiums on the left is to put a 3 here. So I now have 3 lithiums. So my lithiums are balanced, 3 here, 3 here. Nitrogen, well, I have 2 nitrogens here. I have 2 nitrogens, and how many nitrogens do I have here? I have 1 nitrogen. So the only way I can get 2 nitrogens, I cannot use a subscript, so I have to put a coefficient. So I put a 2 in front to give me 2 nitrogens. But hopefully right now you're saying, but wait a minute, Mrs. LaPola, now you have more than 3 lithiums. You have 2 times 3 or 6 lithiums. That's okay. We can go back and change that coefficient once I get my eraser. I can go back and change coefficients as needed to balance the equation. With that 2 there, my nitrogens are balanced, but now I now have 2 times 3, or I have 6 lithiums. So what coefficient is going to go out front? A 6. So now I have a balanced chemical equation. I have 6 lithiums. I have 2 times 3, 6 lithiums. I have 2 nitrogens, 2 nitrogens. So that's our first balanced chemical equation. And when doing chemical equations, sometimes they're small enough where you can balance them upon inspection. But many times you may have a chemical equation that's a bit longer, and it may be more advantageous to draw a chart. And I like doing charts, to draw a chart to keep track of how many of each type of atom you have on each side. And then that helps you keep track as to how much you have on the reactant and product side, and then you can change the appropriate column as needed. What do I mean by that? So I have this second example too of FeBr3 reacting with H2SO4 to give me Fe2SO4 3 and HBr, and I need to balance this chemical equation. So what I'm going to do is I'm going to do a little chart both for my reactant side and my product side, and I'm going to take stock of how many of each atom I have, so I know what I'm starting with. And before I do that, I just want to bring to your attention when I listed the atoms that are present in this species, I have listed them so that they're in order so I can easily compare number of irons on the reactant side to number of irons on the product side. And when I've listed my species, you'll notice that I've listed actually a polyatomic, not just an atom. I listed the polyatomic SO4. Now, if I wanted to, I could have broken that down into sulfur and oxygen when balancing this chemical equation. But I recommend when balancing chemical equations, if you have a polyatomic and it stays together, meaning it doesn't break apart once the product, then I recommend balancing it as a unit, as a groupie, because that's when polyatomics function, that's how they work, as groupies. They stay together. So when I balance my SO4s, I'm going to balance them just as a chunk, as a unit. So for example, when I look at my reactant side, I would say I have one SO4 chunk. On my product side, how many SO4 chunks do I have? I have 3. Because that 3 goes to everything inside the parentheses, I have 3 SO4s. Okay, so now let's go back and let's take stock of how many of the other types of atom we have in reactants and products. On my reactant side, right now I have 1 iron. If there's no coefficient out front, that means that's an implied 1. I have 1 iron. I have 3 bromines. And I have 2 hydrogens. On my product side, I have 2 irons. I have 1 bromine, and I have 1 hydrogen. Okay, so now we've taken stock of number and type of atom or polyatomic that we have. Let's go ahead and start balancing. I've got 1 iron on my reactant side, 2 on my product side, so I better put a 2 in front. That's the only way I can change number of irons. So when I do that, when you put that 2 there, when you change the coefficient, make sure that you change your chart as well. When I put that 2 there, I not only change the number of irons that I have, I also change the number of bromines that I have. So that 2, I now have 2 irons, and I also have 2 times 3, or 6, bromines. Okay, so my irons are good. I've got 2 on my reactant side, 2 on my product side, but my bromines, I've got 6 on the reactant side and only 1 on the product side. The only way I can change number of bromines is to put a 6 out front. So that's a 6 in front of the HBr. So when I do that, I change not only my eraser, I change my number of bromines and the number of hydrogen atoms, both of which are now 6. So my irons are good, both have 2. My bromines are good, both have 6. Hydrogen, I've got 2 over here and 6 over here. The only way I can get 6 over here is if I put a 3 in front of the H2SO4. So that will change my hydrogens and the number of SO4 chunks that I have. So I now have, so I might get my pen here, I now have 3 times 2, or 6 hydrogens. And I now have 3 SO4 chunks. And hey, that works out great, 'cause how many SO4 chunks do I have on my product side? 3. So now I'm at the end of each of my charts. I'm going to go back and make sure that number and type of atom match for each. 2 irons, 2 irons, 6 bromines, 6 bromines, 6 hydrogen, 6 hydrogen, 3 SO4s, 3 SO4s. So that is a balanced chemical equation. So I would encourage you to try the examples that are on the Canvas worksheet, and we will work one more on the next video together.